The question of what would happen if the Earth were to stop rotating for even a second represents not only an interesting thought experiment, but also an important aspect of understanding the fundamental laws of physics that govern our planet. The relevance of this topic stems from the need to recognize how fragile the balance of natural systems upon which life on Earth depends can be. Studying such hypothetical scenarios helps both scientists and ordinary people better understand the mechanisms that ensure our planet's stability, as well as potential threats associated with their disruption. And before we continue, please subscribe and leave a like. The fascination with catastrophic scenarios such as the sudden cessation of Earth's rotation is tied to humanity's inclination to explore extreme situations. Such questions allow us to vividly visualize how different natural processes are interconnected and what consequences might arise from their abrupt alteration. Moreover, these reflections highlight the importance of the laws of motion and inertia which govern not only planetary rotation but also everyday phenomena. The goal of this video is to investigate the possible consequences of a brief halt in Earth's rotation based on scientific data. To achieve this, we must first examine the physical characteristics of the planet's rotation, including speed, angular momentum, and mass distribution. Next, we will analyze how such a stoppage would affect the atmosphere, oceans, geological structures, and living organisms. Finally, we will present scientifically grounded scenarios of how events might unfold, allowing us to assess the scale of a potential catastrophe. This analysis will not only satisfy intellectual curiosity, but also provide deeper insight into the dynamics of our planet. The rotation of the Earth around its axis is one of the key factors determining living conditions on our planet. A complete revolution of the Earth takes approximately 24 hours, creating the cycle of day and night, while also influencing climate, ocean currents, and even the shape of the planet itself. The linear rotational speed is greatest at the equator, reaching about 1,670 kilometers per hour, and gradually decreases toward the poles where it is practically zero. This difference in speed occurs because, unlike a solid body, different parts of the Earth are located at varying distances from the axis of rotation. The centrifugal force arising from rotation plays an important role in shaping the geoid, the figure of the Earth, which is not a perfect sphere but slightly flattened at the poles. This force also reduces the effective acceleration due to gravity at the equator, making objects weigh slightly less there than at the poles. Additionally, centrifugal force affects the movement of the atmosphere and oceans, contributing to the formation of large-scale phenomena such as trade winds and oceanic gyres. The role of Earth's rotation in creating day and night cannot be overstated. Thanks to this process, solar radiation is distributed relatively evenly across the planet's surface, preventing one side from overheating while the other remains excessively cold. If the Earth did not rotate, one half would be in perpetual sunlight while the other would remain in eternal darkness, making conditions for life extremely unfavorable. Moreover, Earth's rotation influences atmospheric circulation, shaping global wind systems that transport heat and moisture between latitudes. Gravitational and inertial forces are also closely tied to Earth's rotation. Gravity holds the atmosphere and water on the planet's surface, while the inertia of motion ensures the stability of rotation. If the Earth were to suddenly stop, inertia would lead to catastrophic consequences. Objects on the surface, including water in the oceans and air in the atmosphere, would continue moving at their previous speed, causing monstrous hurricanes, tsunamis, and destruction. Even a brief halt would disrupt the balance of forces, leading to global catastrophes. Thus, Earth's rotation is not merely a mechanical process but a fundamental factor determining the conditions for life. Its stability ensures the familiar climatic conditions, distribution of heat and moisture, and the dynamics of the atmosphere and hydrosphere. Any abrupt change in rotational speed, even for a short period, would trigger a chain reaction of destructive phenomena, demonstrating just how fragile the equilibrium of natural systems can be. Studying these mechanisms not only helps us better understand our planet, but also assess potential risks associated with hypothetical catastrophic scenarios. Let us imagine a completely impossible scenario from a physics standpoint. The Earth's rotation around its axis suddenly stops for a full second. This thought experiment, while contradicting fundamental laws of physics, allows us to newly appreciate how fragile and remarkable the balance of forces sustaining life on our planet truly is. Let us examine in detail all aspects of this hypothetical cataclysm to understand the true value of the stable world we inhabit. From a physics perspective, an abrupt halt to Earth's rotation would require the application of unimaginable external force. To grasp the scale, Earth's moment of inertia is approximately 8% tangent or bird ad, and its rotational kinetic energy is roughly 6% tangent or bird ad, J. Stopping this rotation in 1 second would demand an enormous braking torque. For comparison, all energy produced by humanity in a year constitutes merely an insignificant fraction of this magnitude. Such an impact could only result from collision with some hypothetical object of colossal mass or intervention by forces currently unknown to science. The first and most devastating consequences would manifest as inertial movement of all unsecured surface objects. At the equator, where linear rotational velocity reaches 1,670 kilometers per h, people, buildings, vehicles, and even topsoil would instantly become deadly projectiles. The physics of this process is terrifying. A 70 kilograms human moving at such speed would possess kinetic energy comparable to multiple artillery shell explosions. Cities would literally be flung into the air, with landscapes becoming unrecognizable within seconds. The hydrosphere would suffer particularly catastrophic effects. Oceans with their enormous mass would continue moving by inertia, creating waves several hundred meters high. These mega tsunamis would crash onto continents with monstrous force, obliterating everything in their path. Coastal cities would vanish instantly, while water masses would penetrate deep inland, redrawing the world map beyond recognition. Even deep within continents, rivers would overflow their banks, creating vast floods. Earth's crust would experience incredible stress. Tectonic plates moving at different speeds would begin colliding and overriding each other. This would cause earthquakes of unprecedented magnitude reaching 13-14 on the Richter scale, far exceeding any seismic events in recorded history. Volcanic activity would intensify hundreds of times. Magma, continuing its inertial movement, would rupture the crust at thousands of new points. Enormous quantities of ash and gases ejected into the atmosphere would create a volcanic winter effect, triggering sharp global cooling. The lithosphere might partially slip relative to the mantle, causing geographic pole shifts. This in turn would alter Earth's magnetic field with all its consequences. Disruption of the magnetosphere would allow deadly cosmic radiation to reach the surface, creating additional threats to all life. Atmospheric consequences would be equally devastating. Earth's air envelope, possessing significant inertia, wouldn't stop instantly. The result would be winds of unbelievable force, up to 1,670 kilometers per h at the equator. For comparison, the most powerful hurricanes in history rarely exceeded 300 kilometers per h. Such winds would completely destroy all surface structures, uproot trees, and strip away topsoil. Air masses colliding with mountain ranges would create heat waves and monstrous turbulent flows. Atmospheric pressure would be radically redistributed. A low-pressure zone would form on the former eastern side, with high pressure developing on the western side. This would trigger global atmospheric circulation restructuring with completely unpredictable climatic consequences. The planet's thermal balance would be disrupted, leading to abrupt temperature changes worldwide. In the first minutes after rotation stopped, the planet would be engulfed by a series of unprecedented catastrophes. Giant tidal waves would obliterate coastal cities. Firestorms would erupt from infrastructure destruction and mass ignitions. Hurricanes of incredible force would reshape landscapes, while countless volcanic eruptions and earthquakes would complete the picture of total devastation. Within weeks, long-term consequences would emerge. Global climate changes from thermal imbalance would cause mass extinction of species unable to adapt. Radioactive contamination from destroyed nuclear plants and industrial facilities would create additional ecological disaster zones. Agriculture would be completely wiped out, triggering global famine. Over decades, complete climatic zone restructuring, atmospheric composition changes, and evolution of new ecosystems would occur. Earth's biosphere would become unrecognizable, with many modern species, potentially including humans, unable to adapt to new existence conditions. If we assume rotation resumes after 1 second, this would trigger another catastrophe wave. Additional inertial loads would finish destroying surviving structures, new giant ocean waves would complete coastal zone annihilation, and further atmospheric disturbances would permanently disrupt climatic balance. Human civilization's survival chances in such a scenario are extremely slim. Potential survivors might include deep underground shelters protected from surface cataclysms, submersibles or underwater bases that withstood tsunamis, space stations if undamaged by atmospheric disturbances and space debris. Even then, survivors would face incredible hardships. The surface would become virtually uninhabitable, resources would be destroyed or inaccessible, and climatic conditions would be extremely hostile. Civilizational recovery would require decades, if not centuries, proceeding under completely new circumstances. While purely hypothetical and contradicting known physics laws, examining this scenario has tremendous value. It enables us to better understand interconnections in complex Earth systems, appreciate rotation's true importance for sustaining life, develop more accurate geophysical models, improve prediction methods for real though less catastrophic disasters. Less catastrophic variants might include gradual slowing of Earth's rotation, which actually occurs but extremely slowly, brief stoppage for fractions of a second, localized rotation disruption in specific regions. Yet even these relatively mild scenarios would cause significant consequences and global changes. This thought experiment compels us to contemplate fundamental questions. How fragile is human civilization facing global cataclysms? How deeply do we depend on fundamental physical laws governing our planet? What is humanity's true place in the universe? How precious and unique is the delicate balance enabling our existence? Even a 1-second rotation stoppage would completely destroy modern civilization and radically alter Earth's appearance. This vividly demonstrates how finely balanced our planet's systems are and how profoundly we depend on rotation's stability. While scientifically impossible, examining this scenario holds enormous educational and scientific value. It helps understand complex interconnections in the Earth system, appreciate fundamental physical process and importance, recognize life-sustaining conditions' fragility, develop new approaches to modeling global systems. Ultimately, this hypothetical scenario serves as a powerful reminder of our planet's preciousness and vulnerability, and how vital it is to protect the delicate balance enabling life as we know it. It teaches us to value our world's stability and approach humanity's impact on global Earth systems more responsibly. Let us imagine two possible scenarios following a hypothetical 1-second cessation of Earth's rotation. The first scenario assumes rotation resumes after that second, while the second posits it stops permanently. Both would lead to catastrophic consequences, though of different scales and natures. In the case of resumed rotation, the consequences would be colossal yet partially reversible. The instantaneous stop and subsequent restart would create a double wave of destruction. The initial impact would affect everything on the surface: meshed buildings, infrastructure, forests, wildlife. The secondary impact, when rotation restarts, would finish off whatever miraculously survived the first. Cities would become piles of rubble, transportation systems would be completely destroyed, and power grids would cease functioning. Coastal regions would suffer particularly, battered by giant tsunamis caused by water's inertia. Planetary ecosystems would experience incredible stress. Forests would be literally swept from the face of the Earth, soil cover disrupted, rivers changing their courses. Marine ecosystems would suffer from monstrous waves and altered currents. However, as Earth's history shows, life possesses remarkable regenerative capacity. Within decades, ecosystems would begin natural recovery. Microorganisms and simple life forms would rebound first, followed by grasses and shrubs. Forests would require centuries to return to former states. Animal life would recover slowest, especially large species. Human civilization would face unprecedented challenges. Survivors would find themselves in conditions resembling the Stone Age, yet with memories of former technologies. Key problems would include lack of clean water, collapsed healthcare systems, inability to quickly restore food production. Decades would be needed to return even to pre-industrial development levels. Some technologies might be lost forever due to destroyed scientific infrastructure and loss of knowledge bearers. The scenario where rotation doesn't resume would prove far more catastrophic. The planet would undergo fundamental changes to all processes. The most immediate consequence would be permanent daylight on one hemisphere and eternal night on the other. The boundary between light and dark would become a narrow twilight zone with the most survivable temperatures. The sunlit side would gradually become a scorched desert with temperatures far exceeding current records, while the dark side would plunge to cryogenic cold. Earth's magnetic field, generated by liquid outer core rotation, would weaken and might virtually disappear within centuries. This would allow deadly cosmic radiation to reach the surface. Magnetosphere loss would lead to gradual atmospheric erosion by solar wind, as happened with Mars. Within millennia, atmospheric pressure could drop to critically low levels, making higher life forms unsustainable without special protective structures. The biosphere would experience mass extinction surpassing all in Earth's history. Large animals and plants unable to adapt would die first. Microorganisms, particularly extremophiles, would last longer, but their existence too would be threatened by radiation and atmospheric changes. Oceans on the night side would freeze, while those on the day side would partially evaporate, creating dense cloud cover in the twilight zone. Marine life would survive only in this narrow intermediate band. Humanity, if any portion survived the initial cataclysm, would be forced to either migrate to the twilight zone or create underground shelters. Technological civilization would likely be unsustainable, requiring completely new approaches to energy, agriculture, and living space organization. Humanity might split into isolated populations, each adapting differently. Interestingly, on a million-year timescale, the planet might reach new equilibrium. The atmosphere could stabilize at new levels, new climate zones form, and possibly new life forms adapted to permanent day or night might emerge. But for human civilization accustomed to day-night cycles, such timescales are meaningless. We would either adapt within generations or perish. Comparing both scenarios shows that even temporary rotation stoppage would cause global catastrophe, but leave some chance for recovery. Permanent cessation would mean fundamental planetary changes to which current life forms are unadapted. This underscores how crucial Earth's rotation is for life, maintaining essential balance between heat and cold, light and darkness, stability and change. From a scientific perspective, examining such hypothetical scenarios helps understand delicate mechanisms maintaining Earth's equilibrium. It reveals connections between seemingly disparate phenomena: core rotation, magnetic fields, atmospheric circulation, and heat distribution. This knowledge serves not just scientific curiosity, but also helps gauge limits of Earth system resilience, especially relevant in our era of anthropogenic planetary impact. Philosophically, this compels reflection on humanity's place in the universe. Our existence depends on Earth's unique combination of physical parameters, and disrupting even one, that is in this case rotation, jeopardizes our survival. This should remind us how fragile our ecological niche is, and how carefully we must treat global systems sustaining us. Practically, such research enables modeling of less catastrophic but more probable changes, like Earth's gradual rotational slowing, which does occur, albeit extremely slowly, or atmospheric circulation alterations. Understanding extreme scenarios helps prepare for real, if smaller-scale, disasters. In conclusion, hypothetical cessation of Earth's rotation, even for 1 second, represents one of the most destructive global catastrophe scenarios. It demonstrates how interconnected our planet's processes are and how profoundly we depend on Earth's fundamental physical parameters. Studying such scenarios, despite their fantastical nature, holds significant value for science, philosophy, and humanity's long-term survival strategy. The theme of Earth's rotation stopping has been repeatedly explored in science fiction, serving as the basis for captivating plots and profound philosophical reflections. Different authors have interpreted this idea in various ways, from strictly scientific approaches to fantastical premises, but all have attempted to contemplate the consequences of such a catastrophic event. The classic film The Day the Earth Stood Still, 1951, while not depicting Earth's rotation stopping directly, plays with a similar concept. In the movie, the alien messenger Klaatu demonstratively halts all technological processes on the planet to show humanity his power. This symbolic moment became iconic in cinema, demonstrating how fragile our civilization is in the face of superior forces. The 2008 remake develops this idea, focusing on ecological catastrophe, though again without directly addressing the cessation of planetary rotation. The disaster film 2012-2009 comes closer to our theme. One scene shows Earth's rotation temporarily disrupted due to crustal displacement relative to the core, leading to global cataclysms, earthquakes, tsunamis, and volcanic eruptions. While scientifically inaccurate in many aspects, the film vividly illustrates the potential scale of such a catastrophe, particularly in its striking depictions of collapsing skyscrapers, sinking streets, and giant waves obliterating everything in their path. In literature, John Christopher's 1969 novel The World in Winter, published in the US as The Long Winter, explores this theme. The author depicts a world where Earth's rotation gradually slows, causing radical climate changes. One hemisphere becomes permanently sunlit, while the other plunges into eternal night, with the story unfolding in the narrow twilight zone between them. The novel is notable for portraying not an instant catastrophe, but a slow transformation spanning generations. Modern science fiction continues to address this theme. James Blish's 1953 novel A Case of Conscience describes an experiment to control Earth's rotation that accidentally stops the planet, leading to catastrophic hurricanes, earthquakes, and floods. The author attempts to provide scientific justification for these events by describing plausible physical processes. The animated film Titan AE 2000 offers an original interpretation. Here, Earth's rotation stops as a result of ancient alien technology, giant engines built to control planetary motion. When this system fails, Earth begins rotating chaotically, leading to apocalyptic consequences. The animated format allows for visually striking, memorable depictions of catastrophe. In Russian literature, Arkady and Boris Strugatsky's 1976 novella Definitely, Maybe, original title A Billion Years Before the End of the World, deserves mention. While not directly about Earth's rotation stopping, it masterfully portrays a situation where natural laws begin behaving unpredictably. Creating an effect incomparable to rotational cessation, the world becomes unpredictable and unsafe. The Strugatskys raise an important philosophical question: how does humanity respond to threats to the established world order? The TV series, The 100 2014 to 2020 presents another perspective. In one season, nuclear catastrophe forces humanity's remnants to live in space while Earth recovers. When characters return, they discover Earth's rotation has changed, causing radical climate shifts. The show explores human adaptation to new conditions and the creation of fundamentally different civilizations. Ishtrewas and Nasabit Buturchi. Video games have also addressed this theme. In Final Fantasy VII 1997, the villain Sephiroth uses magical energy to stop the planet's rotation, intending to destroy it. The interactive format lets players witness consequences firsthand. Crumbling cities, transforming landscapes, panicking populations while attempting to prevent the catastrophe. Science fiction authors have imagined Earth's rotation stopping with varying consequences. Earlier works emphasized physical disasters, earthquakes, floods, hurricanes. Contemporary creators often focus on social and psychological aspects, human behavior facing global catastrophe, new societal forms emerging in post-apocalyptic worlds. Interestingly, the perceived causes of rotational stoppage have evolved. Mid-20th century works typically attributed it to scientific experiments or divine intervention, while modern stories more often cite ecological factors or ancient alien technologies. This reflects shifting human anxieties, from nuclear war fears to climate change concerns. These works hold immense cultural significance. They serve an important function by allowing us to safely experience fears of global catastrophe. Through artistic imagery, we can emotionally prepare for potential, however improbable, cataclysms. Moreover, such works prompt reflection on civilization's fragility and the need for planetary stewardship. Many contain philosophical subtexts exploring human adaptability's limits. How far can we alter our environment? Which technologies truly threaten our planet? Is recovery possible after global catastrophe? These questions grow increasingly relevant amid anthropogenic climate impact. Notably, most depictions present rotational stoppage as survivable. Characters find ways to adapt, build new societies, sometimes even attempt to restore rotation. This reflects optimistic faith in humanity's crisis survival abilities, albeit through radical lifestyle changes. Technical treatment varies widely. Some works provide scientific explanations, others rely on magic or advanced technology. Regardless, the theme's recurring presence demonstrates how Earth's rotation stopping captures imaginations and evokes deep emotional responses. Comparative analysis reveals evolving human attitudes toward global catastrophes, where technological risks dominated mid-20th century concerns. Ecological threats now take precedence. Future interpretations will likely reflect humanity's evolving fears and hopes. Importantly, many works frame rotational stoppage not just as disaster but as humanity's turning point. Characters often use crisis opportunities to build fairer worlds. This connects with apocalyptic myths about world ending and renewal found across cultures. In conclusion, artistic depictions of Earth's rotation stopping serve multiple functions. They help process fears of global catastrophe, explore human adaptability's limits, and contemplate civilization's future. Such works provide valuable emotional and intellectual preparation for potential challenges ahead, both real and imagined. Our investigation into the hypothetical scenario of Earth's rotation stopping, even for the briefest moment of 1 second, has yielded several crucial insights about the fundamental principles governing our planet's existence and life upon it. This analysis reveals that Earth's rotation is not merely a physical phenomenon but a foundational element enabling the very existence of the biosphere and human civilization as we know it. The primary conclusion demonstrates that Earth's rotation is critically important for maintaining all planetary systems in dynamic equilibrium. The daily rotation creates the essential balance between surface heating and cooling, drives global atmospheric and oceanic circulation, and sustains the geomagnetic field that protects us from cosmic radiation. Without this rotation, our familiar world would cease to exist in its current form. Climate zones, weather systems, ocean currents, all these phenomena exist thanks to our planet's constant rotation. From a scientific perspective, an abrupt cessation of Earth's rotation is absolutely impossible without intervention from unimaginably powerful external forces. The law of conservation of angular momentum, one of physics' fundamental principles, makes such an event unachievable in reality. Halting Earth's rotation would require energy comparable to millions of the most powerful nuclear explosions. Even imagining such force acting upon our planet, the consequences would be catastrophic not just for Earth but for the entire solar system due to disrupted force balances. Physical calculations show that even a temporary rotational stop would immediately release colossal kinetic energy. Surface objects would continue moving at original speeds, up to 1,670 kilometers per h at the equator, transforming everything unsecured into deadly projectiles. Oceans, maintaining their inertial motion, would crash onto continents as 100-meter-high waves. The atmosphere, continuing its movement, would generate hurricane-force winds obliterating everything in their path. Tectonic plates would experience tremendous stress, triggering worldwide earthquakes and volcanic eruptions. This thought experiment teaches us a vital lesson about the fragility and delicate balance of planetary systems. Earth is not simply a solid body rotating in space, but an incredibly complex dynamic system where all processes are interconnected. Disrupting one system component mid-rotation causes cascading failure throughout all others. Atmosphere, hydrosphere, lithosphere, biosphere, all these planetary spheres exist in close interdependence, with Earth's rotation serving as the foundation for this precarious equilibrium. Particularly important is understanding that life-sustaining conditions we take for granted actually result from a unique combination of numerous factors. Earth's specific rotational speed, axial tilt, and solar distance collectively create the narrow parameter range enabling complex life. Disrupting any of these parameters destabilizes the system, as clearly illustrated by the hypothetical rotation stoppage. This study also demonstrates how profoundly human civilization depends on planetary system stability. Our cities, agriculture, transportation networks, and energy systems all rely on certain unchanging inhuman timescales conditions. Even temporary disruptions cause catastrophic consequences for civilization, as seen with relatively minor natural disasters. A global catastrophe like rotation stoppage would threaten humanity's very existence in its current form. A crucial philosophical aspect involves recognizing our place in the universe. Humanity exists thanks to a unique cosmic coincidence creating Earth's life-supporting conditions. This should inspire not just gratitude but responsibility for preserving the fragile balance sustaining us. As human activity begins affecting global planetary systems, this awareness becomes particularly vital. Practically speaking, such hypothetical studies hold significant scientific value. They improve understanding of interconnections between Earth systems, help develop global process models, and refine prediction methods for real, if smaller-scale, catastrophes. Examining extreme scenarios helps scientists better understand planetary system resilience limits and potential breaking points. The psychological dimension matters too. Contemplating catastrophic scenarios lets humanity emotionally prepare for potential crises, developing survival and adaptation strategies. History shows civilizations anticipating threats and preparing for them have better crisis survival odds. In broader context, this research reminds us Earth is our only home in a vast, largely hostile universe. Life-supporting conditions represent a rare and fragile phenomenon requiring protection. Modern science knows no other planets as habitable as ours, making its preservation humanity's paramount responsibility. In summary, hypothetical cessation of Earth's rotation, even for 1 second, represents one of the most destructive global catastrophe scenarios. This study vividly demonstrates how interconnected our planet's processes are, and how profoundly we depend on Earth's fundamental physical parameters. It teaches us to value planetary systems' fragile equilibrium and take responsible care of our shared home right of planet Earth. While sudden rotational stoppage itself contradicts physics laws, examining this scenario holds great educational and scientific value. It improves understanding of complex Earth system interconnections, highlights fundamental physical processes' importance for sustaining life, and reinforces our responsibility for maintaining planetary system stability during this era of anthropogenic environmental impact. Ultimately, this research reminds us of a simple but profound truth. Humanity is part of a complex, fragile planetary system, not its master. Our well-being and very existence depend on maintaining this system's balance, which must guide our actions at both individual and civilizational levels. Only by recognizing this dependence and acting accordingly can we hope for a long, sustainable future for human civilization on our amazing rotating planet.